Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Data Structures in Python, Part 6, Queue, Implementation of Queue as List, Practical Implementation, Applications of Queues, Similarities and Differences between Stack and Queue, for the class 12 students of Computer Science. So, let's dive in and get started. In our previous videos, we delved into the foundational principles of a queue, a data structure that mimics a line of people, where the first one to join is the first to depart. Let's recall the basic concepts of queue. Queues are a type of linear data structure that follows the first in first out (FIFO) principle, meaning that the first element added to the queue will be the first one to be removed. In Python, yen queue and dqueue are terms commonly associated with data structures called queues. Yen queue. Yen queue refers to the process of adding an element to the end, rear, of a queue. In Python, you can yen queue an element by using the append method for a list, as lists can be used to implement a simple queue. Let's see an example. In this code, first queue is empty list. After that we append the values 1, 2, 3, and print. When you run this code, it will display the output shown here. This output shows the queue after performing the yen queue operations, and you can see that the elements 1, 2, and 3 have been added to the queue in that order. Dqueue. Dqueue refers to the process of removing the element from the front of the queue. In Python, you can dqueue an element by using the pop of a 0 method for a list, which removes the first element. Let's see an example. Here in this code the queue is empty at first, then elements 1, 2, 3 are added in the queue list. If condition len of queue is greater than 0, front underscore element is removed using pop of 0. Then it gets printed. After deleting all the elements, queue is empty. After running this code, front underscore element will contain the value that was at the front of the queue, in this case, 1, and the queue will be list containing 2, 3. Now, let's delve into their practical implementation. Example 1. Write a program in Python to add, delete, and display elements from a queue using list. Adding is yen queue. Deleting is dqueue. Now, look at line 1 of this Python code. We are initializing an empty list called queue to represent our queue data structure. This program is a menu-driven program. Before that we are defining the functions, yen queue of item, dqueue function, display function and is underscore empty function. In line 3, we are define a function yen queue to add an item to the queue. In line 4, we are using the append method to add the item to the end of the queue list. In line 5, we are print a message to confirm the addition. Next, we are define a function dqueue to remove an item from the queue. In line 8, check if the queue is not empty. In line 9, we use the pop of 0 to remove the item at the front of the queue list. In line 10, we print a message to confirm the removal. In line 11, 12, else, we are printing a message if the queue is empty. Cannot dqueue. In line 14, we are defining a function display to show the current elements in the queue. In line 15, we are checking if the queue is not empty. In line 16, we are printing the contents of the queue list. In line 17, 18, else, we are printing a message if the queue is empty. In line 20, we are defining a function is underscore empty to check if the queue is empty. In line 21, we are returning true if the length of the queue list is 0, otherwise, returning false. In line 23 to line 28, we are starting an interactive menu-driven loop, including the queue operations, yen queue, dqueue, display, quit. In line 29, we are prompting the user for their choice. In line 31, if choice is equal to 1. In line 32, we are prompting the user to enter an element to yen queue. In line 33, we are calling the yen queue function to add the item to the queue. In line 34, 35, elif choice equals 2, we are calling the dequeue function to remove an item from the queue. In line 36, 37, elif choice equals 3, we are calling the display function to show the current elements in the queue. In line 38, 39, elif choice equals 4, we are printing a message to indicate program exit. In line 40, break statement. It exits the loop and ends the program. In line 41, 42, we are printing a message for an invalid menu choice. Now, let's look at the output. Look at the left column. When choice equals 1, it's yen q, so element 22 is added. Again, when choice equals 1, it's yen q, so element 46.5 is added. Now, look at the second column. Again, when choice equals 1, it's yen q, so element x is added. Now, the choice is 3, so it displays the queue list as 22, 46.5, x. Look at the left column. Now the choice is 2, you get the message removed 22 from the queue. The front element 22 is deleted from the queue. Now the choice is 3. It displays the queue list as 46.5, x. Now the choice is 2. You get the message removed 46.5 from the queue. The front element 46.5 is deleted from the queue. Now the choice is 3. It displays the queue list as x. Now the choice is 2. You get the message, removed x from the queue. Now the choice is 3. It displays, queue is empty, as we have deleted all the elements one by one using the dequeue operation. Now, look at the right side. Choice is 4, you get the message exiting the program. Program completed. Try to work it by yourself. Let's see the applications of queue. Printer queue. It manages and prioritizes print jobs in multi-user environments. Let me explain. Queues are vital for handling multiple print requests in a network printer. When the printer is busy, new print requests are queued on the hard disk. The queued jobs wait until the printer becomes available. Queues maintain order in a multi-user printing environment. Second point is single-user systems. Task scheduling and orderly task execution. Let me explain. Queues are utilized in single processor systems with one user at a time. Users requesting system access are placed in a queue. The queue ensures fairness and order for user access in a single-user environment. Third application is real-time systems. Handling interrupts in the order they occur. Let me explain. Real-time systems face interrupts that need immediate handling. For sequential and timely interrupt processing, FIFO queues are used. FIFO queues maintain the order of interrupt handling in real-time systems. Fourth point is simulating wait, demonstrating orderly execution in scenarios involving waiting. Call center phone systems use a queue to hold people in line until a customer representation gets free. Fifth point is playlist ordering. Managing the order of songs in playlists. Buffers on MP3 players and portable CD players, iPad playlists, etc., and songs to the end and play from the front od the list. Let's see the similarities and differences of queues and stacks. Similarities. Linear data structures. Both queues and stacks are linear data structures, meaning they organize elements in a linear or sequential manner. Addition and removal of elements. Both data structures support operations to add and remove elements, although with different rules for these operations. Let's see the differences between queue and stack. Queue follows first in first out, FIFO, principle, whereas stack follows last in first out, LIFO. In queue, the primary operations are yen queue, add to rear, dequeue, remove from front. In stack, the primary operations are push means add to top and pop means remove from top. Use cases. Q. Maintaining order. Process items in the order they arrive, for example, print job management, BFS breadth first traversal. In stack. Managing function calls, evaluating expressions, for example, programming function call stack. In real-world analogy, in queue of people waiting in line at a ticket counter. In stack of plates, where you add and remove from the top. Implementation options. In queue arrays, linked lists, circular queues are used. In stack arrays, linked lists are more flexible for resizing. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Watch the upcoming videos, Relational Database and SQL, Part 1. Introduction, Database Management System, DBMS, Need for DBMS, Components of a Database System, Advantages of DBMS, DBMS Models. You can check the link in the description box given below.